Welcome to this lecture. In this video, I will discuss Laplace transform of ramp signal and parabolic signal. The first one we consider Laplace transform of ramp signal. So it is shown graphically here. So the signal value is linearly increases with time. So we define it as R of t equals to t when t greater than or equal to 0 and its value is 0 when t less than 0. So this is the region where t greater than 0. So in this case its value is increases with time. So we can write it as t. So we try to find the Laplace transform of r of t, that is Laplace transform of ramp signal r of t equals to integral over 0 to infinity r of t e power minus st dt, that equals to integral over 0 to infinity. So r of t in the positive axis, the value is t into e power minus st dt. So this function has the two signals, one is t and second one is e power minus st. So if we assume t as a u and e power minus t is a v, so then it look like integral over 0 to infinity u into v dt. So now we recall the formula of integral uv dt. So integral uv dt is equal to u integral of v dt minus integral of du by dt integral v dt. So there are two integral function, integral of v dt and second time also integral of v dt is there, and one derivative function, so which is derivative of u. So in this case u is t and v is e power minus st. So derivative of u with respect to time is 1, and similarly so integral of v dt equals to integral of e power minus st dt gives e power minus st by minus s. So these two terms, this derivative term and integral of v dt term, we use in this formula. Now we write integral of t into e power minus st, which is in the form of integral uv dt using this formula. So first term u integral of v dt. So u is t integral of e power minus st dt, that is integral of v dt gives us e power minus st by minus s. The limits are 0 to infinity minus integral of du by dt. So du by dt is already determined here, so that is 1. Integral 0 to infinity, so 1 into integral of v dt, so that is e power minus st by minus s dt. So that equals to, if we apply the limits in the first term, so this term becomes 0 because t is infinity now, infinity into e power minus infinity, so that e power minus infinity value is 0. So infinity into 0, so that gives 0 function, and minus if you substitute lower limit, so then also it gives 0. So overall the first term becomes 0 minus the second term integral over 0 to infinity e power minus st by minus s dt. That equals to, so this minus is taken out, then we can write it as 1 by s integral over 0 to infinity e power minus st dt. That equals to 1 by s integral over 0 to infinity e power minus st. So this is in the form of e power minus at. So we write it as e power minus st by minus s over the limits 0 to infinity. That equals to 1 by s of, so upper limit is infinity, so that gives e power minus infinity minus of lower limit e power 0 by minus s. 1 by s e power minus infinity is 0 minus 1 by minus s. So that equals to 1 by s into minus 1 by minus s, that gives 1 by s equals to 1 by s square. Therefore, Laplace transform of r of t is 1 by s square. And coming from this function, we can write the ROC of this ramp signal. So this integral function becomes finite for the values of s greater than 0. So this defines the ROC of this ramp signal. So that is s greater than 0. So this is about the ramp signal whose Laplace transform is 1 by s square and ROC is s greater than 0. The second one is Laplace transform of parabolic signal. It is represented graphically here. So for t greater than 0, its value is t square, and for t less than 0, its value is 0. So we define this function as p of t is equal to t square when t is greater than or equal to 0, and its value is 0 when t less than 0. We find the Laplace transform of this parabolic function. So Laplace transform of p of t equals to integral over 0 to infinity p of t e power minus st dt. That equals to integral 0 to infinity. So p of t is t square into e power minus st dt. So this function is having the two signals t square and e power minus st. If we assume t square is u and e power minus st is v, then it is in the form of integral 0 to infinity u into v dt. So we write the formula of integral of u v dt equals to u integral of v dt minus integral of du by dt into integral of v dt. So this function consists integral of v dt two times. So therefore, so before proceeding the calculation, so we find the integral of v dt separately and du by dt separately for simplification of this procedure. So integral of, so here in this case u is equal to t square and v is e power minus st. So we find du by dt, that gives 2t, and integral of v dt equals to integral of e power minus st dt. So that equals to e power minus st by minus s. So now we use these two derivative and integral of v dt in further simplification of the problem directly. So now we use the u term, that is t square integral of v dt, which is calculated as e power minus st by minus s. This is first term and the limits are 0 to infinity, minus the second term of formula integral over 0 to infinity du by dt, which is 2t, into integral of v dt, so that is e power minus st by minus s dt. So if we substitute the limits of the first term, so this gives 0, minus 2 is a constant, we can write outside, and minus s is there in the denominator, so we can write minus side outside, so minus into minus becomes plus. So integral over 0 to infinity t into e power minus st dt. That equals to 2 by s integral over t into e power minus st. Again we have the two functions here. So one is t and second one is e power minus st. So we assume u as t here and v is e power minus st. So again we follow the same formula of integral uv dt, and we write the first term is t into e power minus st by minus s over the limits 0 to infinity, minus the second term of formula consists of integral of du by dt, so that gives 1, integral of v dt, so that is e power minus st by minus s dt. So that is 2 by s, the first term. After substituting the limits, it becomes 0, minus, and this minus s we can write outside. So then it becomes plus 1 by s integral e power minus st dt. So that integral limits are considered 0 to infinity. That equals to 2 by s of 1 by s, and this becomes e power minus st by minus s with the limits 0 to infinity. Yes. So now we apply the limits for this function. So we will get 1 by s of e power minus st, that is e power minus infinity, minus lower limit e power 0 by minus s. So that equals to 2 by s of 1 by s. E power minus infinity value is 0, minus 1 divided by minus s. That gives 2 by s of 1 by s, and minus 1 by s, minus minus cancel, and this gives 1 by s, and the final value is 2 by s cube. So this is Laplace transform of signal t square. So we write Laplace transform of t square or parabolic signal into u of t is indicates causal signal, so equals to 2 by s cube, and ROC of this function is, we can find from the integration term, e power minus st into t square. So this integral function is finite for the values of s greater than 0. So that is ROC of this function is exist for real part of s greater than 0. So that is nothing but sigma greater than 0. ROC of this function is s greater than 0. Thank you.